Rahim. Assalamu alaikum, dear students. This is our next problem. Problem, as usual, chosen from the book Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. Okay, the effective vibrational force constant of carbon nitride is 1.017 into 10 to power 4 electron volt over nanometer square. Nano meaning nano standing for 10 to power minus 9. Okay, relative to the ground state, find the energies of the first and second excited vibrational states. Okay, dear students, here only vibrations are under consideration. Rotations are not under consideration. Okay, the effective vibrational force constant of carbon nitride. Dear students, here atoms are of carbon and nitrogen, but molecule is not carbon nitrogen, it is carbon nitride. Okay, there are so many examples of this nature, that atom is of such pronunciation, of such um, pattern that similar to nitrogen, but after becoming molecule, it changes its name from nitrogen to nitride, from bromine to bromide, from iodine to iodide, and so on. Okay, so dear students, first we move to helping tools. These helping tools will serve to develop a foundation to understand this problem. Okay, helping tool number 1. In helping tool number 1, reduced mass of a diatomic molecule has been defined or expressed mathematically. Okay, reduced mass of a diatomic molecule, Mr, where R standing for reduced has been written as a subscript of M, which stands for mass. Okay, Mr reduced mass is equal to M1 M2 over M1 plus M2, where M1 is the mass of atom number 1 and M2 is the mass of atom number 2. That is, reduced mass of a diatomic molecule is equal to product of the masses of the atoms 1 and 2 divided by the addition of the masses of atoms 1 and 2. Okay, in table number 2, in table, not table, in helping tool number 2, a table has been shown. Actually, this table is usually given in almost every book of physics, in appendix at the end of the book. But actually, this table in which chemical properties of elements are described usually consists of so many pages, But here, in order to develop our basic idea about carbon nitride, we have shown a little part, just a part of that table. Okay, so in this table, first of all, element hydrogen comes. Uh, Hydrogen, atomic number of hydrogen is 1 and mass number is 2. Okay, after hydrogen several other elements come, and then comes carbon, and then comes nitrogen, but we have chosen just 3 parts of that table. Okay, so first we come towards carbon. carbon atomic number of carbon is 6 and mass number of carbon is 12. Yes, students, here it becomes relevant that how do we decide that its mass number is 12. Dear students, if we make a comparison among if we make a comparison among the values written in serial number 10, 11, 12, 13, 14 and 15, then we come to conclude that value given at 12, which is 12.000000, is enough different from remaining values. The most important thing about this 12.000 is that its abundance is given as 98.89%. Okay, so we will choose this value. Okay, carbon 12.0000 98.89%. Now we come towards nitrogen. Okay, nitrogen atomic number is 7 and mass number is 14. Okay, here dear students, once again the same question arises that how do we decide that mass number of nitrogen is 14. If we compare the values given in serial number 13, 14, 15, 16 and 17, then we come to conclude that value of serial number 14 is enough different from serial number 13, 15, 16 and 17, because in front of serial number 14 it is written that 99.63%. Okay, so this value against whom 99.63% is written as abundance, we will choose this value. Okay, so in case of carbon we will choose this value 12, 98.89, and in case of nitrogen we will adopt this value 14.003074, having abundance 99.63%. Okay, dear students, in this helping tool number 3, a table has been shown which has been used many times in our previous problems or videos. From this table, speed of light will be used in our value of speed of light will be used in solving our problem. Moreover, value of Planck's constant H will be used, but it will not be used as it is. It will be used in a modified way or modified manner. Okay, modified way or manner means this Planck's constant H will be divided by 2 pi. And after dividing it by 2 pi, it will be denoted by H cut or H bar or H reduced. Okay, so we are concerned with H cut or H bar or H reduced rather than simply Planck's constant H. Okay, moreover, dear students, here 1 U equal to 931.5 million electron volt over C square, this value will also be used. Okay, now we come towards our solution. Okay, in a formal manner. Okay, let us first calculate the reduced mass using the relation Mr equal to M1 M2 over M1 plus M2 of carbon nitride made with carbon 12 and nitrogen 14 as mass of carbon 12 and nitrogen 14 equal to mass of carbon 12 into mass of nitrogen 14 divided by mass of carbon 12 plus mass of nitrogen 14. Okay, in accordance with this formula. Okay, nothing more. We have just adopted this formula and we have used 2 values which we had emphasized in a tool in which a table regarding chemical properties of elements was shown. Okay, so after simplifying this, we come to conclude that reduced mass of carbon nitride is 6.46 small u. Small u means stands for atomic mass unit. Okay, small u stands for unit, and this unit is atomic mass unit. Okay, now we move to next part of this problem. Okay, we know that vibrational energy is given as, we know that vibrational energy is given as E vib, E vibration. Here vibration vib is written as a subscript of E. E vib is equal to h cut or h bar or h reduced or Planck's constant h divided by 2 pi into within under root k over mr. K is force constant and mr is the reduced mass. Okay, using k equal to 1.017 into 10 raised to the power 4 electron volt over nanometer square, from where we have taken this value. This value is given in a statement. Okay, this value of force constant k has been provided in this statement. Okay, moreover, dear students, there are many tables of this nature in almost every book of physics which contain this type of data in which value of force constant is given. Okay, however, to the extent of solving this problem, we are not taking resort to this table. Okay, we are just emphasizing on the value provided in the statement. Okay, moreover, h cut is equal to this. Okay, how this h cut, the value of Planck's constant h is given in the table, and we have our self divided that Planck's constant h by 3.24. Okay, because we have divided h Planck's constant h by 2 pi, and we know that pi is a very special number. Pi is actually 22 by 7, and its decimal representation is non-terminating, non-repeating. It goes endlessly. Okay, however, usually we take its value only up to 2 decimal places as 3.14. Okay, so when pi is 3.14, then 2 pi will be equal to 6.28. Okay, so dear students, using k equal to this provided in the statement, h cut equal to this, and mr equal to this, which we have calculated in the previous page of this word file. Okay, using this in equation number 1, we get E vib, E vibrational energy, equal to this Planck's constant divided by 2 pi into value of k provided in the statement divided by 6.46 u. Okay, now what to be done next? First of all, we will eliminate this unit. Which nature of unit? Atomic mass unit. Okay, first we will eliminate this small u by substituting its value from the table, in which values of various physical constants have been given. Okay, so this implies that E vib vibrational energy equal to this into this over this. Okay, so what we have done, we have used the value of atomic mass unit u. Yes, we have done so. Okay, in the next step, dear students, here it is not appropriate to explain every step in this simplification, because some simplifying steps have been merged, due to which um, it is due to which it is quite appropriate if we mention that we have eliminated such constant with such value. Okay, so dear students, here first of all we have eliminated value of u. Okay, atomic mass unit u, and that value has become in terms of million electron volt over c square, c is speed of light. Okay, in the next step we will eliminate c, because c value of c is 2.998 into 10 to power 8 meter per second, which is usually written in a rounded form as 3.0 into 10 to power 8 meter per second. Okay, so in place of c square we will get 9 into 10 to power 16 meter square per second square. Okay, so meter square per second square, and this meter square per second square may be cancelled with some other. Moreover, dear students, yes, one more simplifying step involves this substitution elimination, that nanometer. We know that nano stands for 10 to power minus 9, so square of nanometer will become 10 to power minus 18 meter square. Okay, so this meter square of nanometer square, this meter square will have a comparison with the meter square of c square, speed of light. Okay, so these two meter square may be cancelled or adjusted in one way or the other. Okay, so one more simplifying step involves this million electron volt. Okay, this million stands for 10 to power plus 6. Okay, so this capital M will also be eliminated or substituted by 10 to power plus 6. Okay, so in this way, dear students, units will be reduced and cancelled with their concerned units. Okay, so here one, this is electron volt and this is million electron volt. Million has been replaced by 10 to power 6, and hence this electron volt has a compatibility with this electron volt, and so these two will also be cancelled or adjusted in one way or the other. Okay, so just this is just a simplification. Okay, nothing else. Okay, so putting these values in it, E Vib or E vibration or vibrational energy becomes equal to 0.2574 electron volt. Okay, vibrational energy E Vib becomes equal to 0.2574 electron volt. Then this implies that first excited vibrational state is at E equal to 0.2574 electron volt above the ground state. Okay, because in problem statement we are asked to describe the excited state above the ground state. Okay, so this implies that first excited vibrational state is at E equal to 0.2574 electron volt above the ground state, and this also implies that in continuation of the above, this implies that second excited vibrational state is at 2E. Okay, second state will be E multiplied by 2, which becomes equal to 0.513 electron volt within bracket above the ground state, because in the statement we are required to have our answer in comparison with the ground state. Okay, so these two values are our answer. Moreover, this is the end of our problem. However, In addition to this ending, it is hereby clarified that this problem actually contains two parts, A and B. But in this solution, in this video, in this sitting, we have just solved part A of this problem. Okay, due to any reason, we are for the time being unable to solve part B of this problem. Okay, this part may be taken in some subsequent sitting, or it may be omitted. Okay, so this is the end of our video, this is the end of our problem. Till next video, till next problem, Allah Hafiz.